Alright, in this final installment, we will find the extended echelon form of this matrix, identify the matrices C and L, and find linearly independent sets that span the null space of A, row space of A, column space of A, and null space of A transpose. Alright, well, let's get down to it. I'm going to go ahead and do this one by hand. It's not too hard. Kind of fudged it so it wouldn't be too hard. Here, let's go back and go here. Okay, so A was 143.22.022.101. -1. Okay, so let's see. We're going to have to eliminate the 1 there. So that looks like we have minus R1 plus R3 gives me 143.022. This gives me 0, minus 4, and minus 4. And then this is going to give me, sorry, I forgot the extended echelon form. That's 100.010. Now, since minus R1 plus R3 is going to give me minus 1.01. All right, now, to get rid of this minus 4 here, we're just going to add 2R2 plus R3, and we get 143.100, 022, 010. Then we're going to get 0. 2R2 plus R3 is 0. 2R2 plus R3 is 0. 2 plus minus 1, 2, and 1. Okay, so the next draw operation is going to be to get rid of this 4. We can take minus 2R2 plus R1. Let's go ahead and do that. And we're going to get 143.100. Oh, I'm sorry, too fast. 1, then minus 2 times 2 plus 4 is 0. Minus 2 times 2 plus 3 is minus 1. Minus 2 times 0 plus that is 1. Minus 2 times 1 plus 0 is minus 2. Then here I have a 0. And then here we have, let me go ahead and multiply row 2 by 1/2 also, because that's the final thing I need to do. 1, 1, 0, 1/2, 0. And then this one goes 0, 0, 0. Minus 1, 2, 1. Okay, finished with my REF. So this is my extended echelon form of A. So that finishes my part A. All right, now for part B, I need to identify C and L. So let me go ahead and draw my lines. Remember that A was 3 by 3, so I'm going to draw the middle down here. And identify the 0 block here. So I take that across, and I do that. All right, so my C is a top left block, 1, 0, minus 1, 0, 1, 1. And my L is the lower right block, minus 1, 2, 1. All right, so that's my C and my L. So let's go ahead and find the spaces, different spaces. For instance, let's take the null space of A. Well, null space of A is just equal to the null space of C. Okay. And C is in REF form, so we should be able to find the null space of C fairly quickly. In fact, as we've done before, you see the free variable is the third one. So if we set the third free variable equal to minus 1, then we can just read off the first variable is also going to be minus 1, and this one's going to be 1. And you can verify that this works. If you multiply our original matrix, which was here, times minus 1, 1, minus 1, you will get 0, 0, 0. So this is okay. All right, so the next one was row space of A. Similarly, the row space of A is equal to the row space of C. And so that's equal to the span. Here, I'm sorry, I should say the span of this is the span of this vector. So the row space of C is going to be the span of the rows of C, and the rows of C were 1, 0, minus 1, 0, 1, 1. Okay. So next one was the column space of A. The column space of A is also equal to the column space of C. No, I'm sorry, it's not the column space of C. It's the column space of A is identified by the pivot columns, and the pivot columns were the first two columns. So here I should say it's the span of the pivot columns. Okay. And in this case, the pivot columns were columns 1 and 2, so that's going to give me 1, 0, 1 and 4, 2, 0. Equals the span of 1, 0, 1 and 4, 2, 0. Right. So that gives me the column space. Then finally I have the left null space, which is the null space of A transpose, and that's equal to the row space of L. And the row space of L is what? Well, L is minus 1, 2, 1. So I can write that as, again, he writes it as column vectors like this, minus 1, 2, 1, like this. But in order to verify this, what you would do is multiply the row vector minus 1, 2, 1 on the left of A. So let's verify that. We could either do that or do the null space of A transpose. So let's check. Let's do the null space of A transpose. Let's get A transpose. So let's remember what A transpose is. The first row of A was 1, 4, 3. So the first column of A transpose is 1, 4, 3. Okay. Second row of A was 0, 2, 2. Second column of A transpose is 0, 2, 2. Third row of A was 0, 1, 0, minus 1. I think that's a minus 1. Let's check. I'm pretty sure that's a minus 1. 1, 0, minus 1. So last column here is 1, 0, minus 1. And let's cross our fingers. What's that doing? 1, 0, minus 1. Let's cross our fingers and make sure that this works here. Multiply by minus 1, 2, 1. All right, if we do that, the first row gives me minus 1, 0, 1, gives me 0. That's a good sign. Minus 4, 4, 0 gives me 0. That's a very good sign. Minus 3 plus 4 minus 1 is 0. So that checks out. Okay, so that's how we got the four spaces in terms of C and L, and that's it.